Good morning. Today's session we will discuss about the glycosides, introduction and classification. Myself D. Shyam Sundar, working as Associate Professor at School of Pharmaceutical Sciences in the Department of Pharmacognosy, Vistas, Chennai. So glycosides are the molecules in which the sugar part is bound to a non-sugar part. Glycosides play numerous important roles in living organisms, like converting the toxic substances into a non-toxic substance. It acts as a source of energy, and also it plays a vital role in the protection of the plant against bacteria and these other diseases. So plants store important chemicals in the form of inactive glycosides. If these chemicals are needed, the glycosides are brought in contact with water or an enzyme, and the sugar part is broken up, making the chemical available for use. So many such plant glycosides are used as medications. Formally, a glycoside is any molecule in which the sugar group is bound through its anomeric carbon to another group via a glycoside bond. So the sugar component is known as a glycone, and the A sugar part or the non-sugar part is known as A glycone or genin. So the glycone part can consist of a single sugar, which is considered to be as monosaccharide, or it may have several sugar groups, which is called as oligosaccharides. A glycosidic bond is a certain type of a functional group that joins alcoholic group of a carbohydrate molecule to an A-glycone molecule. So a substance containing a glycosidic bond is called as a glycoside. Classification of glycosides. The classification of glycosides is based on the following factors, like the nature of the glycone, the number of sugars, the nature of glycoside, the botanical source, the therapeutic uses, the type of glycosidic bond, the glycosidic linkage, and the chemical nature of A-glycone. So let us look into this one by one in the forthcoming slides. So classification based on glycones. So if the glycone part of a glycoside is glucose, then the molecule is said to be glucoside, and the example is senoside. If the glycoside is a rhamnose, it is called as rhamnoside, and you can find this in frangulin. If the glycoside is a digitoxose, it is called as digitoxide, and you can find this in digoxin, a cardiac glycoside. Similarly, if it contains both glucose and rhamnose, you call it as glucorhamnoside, and the example is glucofranculin. If it contains rhamnose and glucose, it is called as rhamnoglucoside, and the common example is rutin. And if it contains glucouronic acid, then the molecule is called as glucouronide, which you can see that in gum arabica. The other forms of classifications based on the number of sugars. If the glycoside contains one sugar, then you call it as a monoside. An example for it is salicin, where you can find only one sugar attached to it. Whereas in case of diosmin, which is an example for a two sugar, which consists of two sugar components, and it is called as biocides. And in case of digoxin, where you can find three sugars, they are called as triosides. The next classification is based on the nature of glycoside. So the primary glycoside, which is actually present in the plant, example being purpura A, and the secondary glycosides which are derived from the primary glycosides, from purpura A, you can get digitoxin by hydrolysis. The next classification is botanical source. Digitalis glycosides, it is obtained from Digitalis purpurae, and the senna glycosides from the senna sites. The next type of classification based on therapeutic use, which includes a wide variety of therapeutic uses for the glycosides, that includes analgesic glycosides, purgative glycosides, cardiac glycosides. So classification of glycosides based on their therapeutic effects, where the drugs which is mainly acting on the heart, which helps in the treatment of congestive heart failure and also to treat cardiac muscle stimulators. The examples being the digitalis glycosides, digoxin, digitoxin, and gitoxin, and also you have the strophanthin and silarin A and B, which is obtained from the white skill bulbs. All has effect on cardiac muscle. Then you have the laxative groups, which includes the senosides A, B, C, D, and you have the cascaroids and the aloin and the barbolin from aloe vera and aloe barbidans. Then there are drugs which act as irritant groups, which is singerin and cinalbin. The salicin acts as an analgesic and antipyretic, where the salicin undergoes hydrolysis and gives rise to salicylic acid. The rutin plays an important role in blood vessels in maintaining the elasticity, and you have the anti-inflammatory groups like aloin and the glycyrrhizin, which is used in the treatment of peptic ulcer. So based on the type of the glycosidic bond, we can have the alpha glycosides and the beta glycosides, where the alpha glycosides you can find the hydroxyl group on the same plane and that is below, and if it's on the hydroxy group is above the plane, then you call it as a beta glycosides. So depending upon the glycosidic bond which lies above or below the plane of the cyclic sugar molecule, the glycosides are classified as alpha glycosides and beta glycosides. The next important classification is based on the linkage, where the A-glycone is linked to a sugar molecule through a linkage of O, then it is called as O-glycoside. If the A-glycone is linked to the sugar, the help of a carbon, so it's called as C-glycoside, and the A-glycone is linked to a sugar with a sulfur, then it is called as S-glycoside, and if it is through N, then it is called as N-glycosides. So these are the examples where you can see that glycosides in senosides is linked through O. So it comes under the classification of O glycosides. Whereas in case of barbolin, you can see that it is the linkage is through C. So it is a C glycoside. And in case of sinigrin, you can see the linkage is through S. And in adenosine, you can see that the linkage is through N. So based on the type of linkages between A glycone and the glycone part, it can be broadly classified into O, C, S and N glycosides. So apart from that, glycosides can also be classified based on the type of A glycone, the non-sugar moiety, and the classifications include the anthraquinone glycoside, simple phenolic glycoside, thioglycoside, flavonoid glycoside, steroidal glycoside or cardiac glycoside, saponin glycosides, coumarin glycosides and cyanogenic glycosides. Let us see a few examples. The anthraquinone glycosides can be cited in senna, aloe, rhubarb. The sterol or the cardiac glycosides are obtained from the digitalis, the foxglove leaves or the squill. The saponin glycosides can be obtained from licorice, ginseng, diascorea, and the cyanogenetic and cyanophoric glycosides you can find in bitter almond. Then you have the thiocyanates from black mustard, flavone glycosides in ginkgo or the routine, and aldehydes glycosides in vanilla, phenol glycosides in beerberry, and the steroidal glycosides in solanum, uh, bitter and miscellaneous glycosides in gentian. So these are few examples of the classification based on A glycone and their respective plant sources through which you can obtain them. With this, we are completing the introduction to glycosides and its classification. Thank you for watching this video.